Now we'll do the math problem. And you know what's going to happen? I'm going to post 4 videos today. 3 of them are going to be math related. 1 of them is going to be me explaining my immune system. That video is going to get like 50 views. This video is going to get like 4. Mark my words. Just saying. That one might go viral. You know what I mean? I challenge you all to share the link to me explaining my immune system to people. See if we can get it to 100 views before the end of the weekend. All right. Here we go. Ready? Write all terms as variations of sine, cosine, or tangent. We have tangent, and no cosines or sines to go along with it, so we're good. Does the new equation have a squared trig term and a non-squared trig term? No. It has just the squared tangent. Okay, so we're here. Use inverse operations to isolate the trig term. This problem is very similar to the one we just did, right? So we're going to divide by 3, and we have tangent squared x equals 1/3. Now we have to take the square root, just like we did in the previous problem. If you didn't watch the previous problem, go back and watch the previous problem. It'll be like example C or D or whatever. Whatever letter comes before this one. So we have to take the square root of both of these to isolate the trigonometric term. There it is. But when we take the square root of 1/3, we got to do a little work here because we get positive and negative outputs. That's the first thing. Every time we have to take the square root, we have to include positive and negatives. The positive and negative output, I should say. And this is the square root of 1 over the square root of 3. Right? When we take the square root of a fraction, we can take the square root of the top and bottom separately. Well, that looks like this. Because the square root of 1 is 1, and the square root of 3 is the square root of 3. Now, I'm not supposed to keep radicals in the denominator. So I have to rationalize this. What does that mean? That means I have to multiply by radical 3 on the top and the bottom there. And the result of this, now we did a lot of this back in Unit 4, I hope you recall. Every time we were doing tangent, it felt like we had to flip something over and multiply and get that radical out of the denominator, so on and so forth. Now here, after we simplify this, 1 times radical 3 is radical 3. Radical 3 times radical 3 is just 3. Now we have this situation. Okay, let's compare where we're at now to where we were at in the previous problem, in the opener. In the previous problem, we got to here, and we said, okay, this is an x coordinate because we're taking the cosine of some angle and getting that number. Because we're doing a problem with cosine, this is an x coordinate. Compare that to the opener, we were using a sine function. So we could say, okay, tell me the angles that have this y coordinate. When we do tangent, we're not looking for coordinates. We just got to know what types of angles have tangent values of radical 3 over 3. Well, radical 3 over 3, that's 2 3's. And we talked about this in a video yesterday. Okay, or in a lesson yesterday, should I say. Where if there are 2 3's in this tangent ratio, we're talking about angles that are pi over 6. Every time you get radical 3 over 3 for your tangent, you're talking about pi over 6 angles. Okay? And because we have both positive and negative solutions, because we have both positive and negative values here, we don't have to worry about which quadrant to go in. Again, this was explained yesterday. But for tangent x, anything that falls in the first, any angle that's in the first quadrant will have a positive tangent value. Anything here will be negative. Any angle in quadrant 3 will have a positive tangent value, and any angle in quadrant 4 will be negative. But because of this sweet little treat, we don't really have to worry about that. We're going to take all the angles that go around the unit circle. And those are all of the pi over 6 angles. Those angles are pi over 6 and anything else labeled as a pi over 6, like 5 pi over 6, 7 pi over 6, and 11 pi over 6, plus 2 pi n. There you go. All right. Here is where we talked about this. Okay? Where we said there's 3 tangent values you need to know. Radical 3 over 3 is all the pi over 6 angles. When the tangent is equal to 1, it's all of the pi over 4 angles. And when tangent of x is equal to radical 3, it's all of the pi over 3 angles. So it's been talked about. We talked about it in Unit 4. We talked about it earlier. I'm not going to explain that anymore. That's just something you got to know. All right? Where were we? Here? Okay. I think we skipped one. Let's go back. Yeah, I skipped this one. This will be the next video.